just a few days here at Kennedy Space Center, SpaceX is going to be launching its Falcon Heavy rocket. Over my left shoulder here, a historic LC-39A. On top of it will be NASA's Psyche space probe heading to the asteroid, also named Psyche, and it's pretty exciting. There's a lot going on here. We're going to an asteroid that we don't really know much about. We have a hypothesis about, but we don't really know what it is. We're testing out some laser communications out in deep space. There's a lot going on here, so we spoke to some people here at Kennedy Space Center to hopefully get you guys an idea of what's launching. Here's Maria talking about what even is Psyche.
So Psyche is a discovery mission. It got selected as part of the Discovery program in 2017, and before that there was a lot of effort put into like the proposal and the selection process, but it was officially selected in 2017, and that's when I joined the program as well. And Psyche is very exciting because it's going to investigate, orbit an asteroid with the same name. The asteroid is also named Psyche, and we believe is the core of an early planetesimal, and this early planetesimal that was on the way of becoming a rocky planet, it got hit by other bodies that stripped its mantle and left this core for us to go explore. It's very easier for us to send a spacecraft to investigate Psyche than to try to reach the center of our Earth to understand it better. So that's what Psyche is going to do.
So we're going to an asteroid. Like, we've done this before. We kind of know, what these things are, but this one's weird, right? It's supposed to be possibly, this solid metal core, and we've just got back with OSIRIS-REx, bringing back samples, and we're not going to get samples this time, sadly, but, what is the difference between, this and OSIRIS-REx and the asteroid that I've visited and the asteroids that we visited before? Like, what makes this one so unique?
Yes, so Psyche, we believe, and then again, this is a hypothesis, right, that we want to corroborate, but we believe it's mostly made of metal, right? So Psyche is attractive because we think is the core, could be the core of an early planetesimal, and we've never seen such a body, right? We've never seen a body that is so high in iron content that we believe, we have indication that could be the core. And if it's not a core, it could be equally interesting because then we don't have a hypothesis for it, right? So in this case, we're not gonna retrieve a sample, right? We're orbiting the spacecraft, where the asteroid, we're taking measurements of its magnetic field, its composition, its topography to try to corroborate this hypothesis of it is a core, and if it's a core, what does it mean for the formation of planets in the solar system?
Maria also talked about the instruments that are going to be on the spacecraft. What are we going to be using to study this asteroid, and how are we going to tell whether or not this is something that we're going to find again, or this might be a one in the solar system type object?
Yeah, so we have 3 science instruments and 1 technology demonstration. The technology demonstration does its mission before we reach Psyche. So the science instruments are a magnetometer, which measures the magnetic field of Psyche, and you can imagine measuring the magnetic field is key to determine if the asteroid is a core or not. Then we have a gamma ray and neutron spectrometer, and the gamma ray and neutron spectrometer measures gamma rays and neutrons that get emitted from the surface of Psyche, and by measuring those gamma ray and neutron emissions, we can determine the composition of the asteroid. And then finally, we have an imager, which consists of 2 cameras that serve to determine the mineral composition of the asteroid, as well as characterize its topography. So these 3 instruments form the scientific suite of instruments that allow us to determine if Psyche is a core and satisfy the mission objectives. And then on the way to Psyche, we are going to demonstrate high data rate optical communications using the Deep Space Optical Communications Technology Demonstration, what we typically call DSOC. DSOC is going to operate at Earth's commensurate between Earth and Mars, and is going to demonstrate like 200 to 2 megabits per second data rates depending on the distance from Earth.
Okay, wait, she talked about one item there at the end that we need to talk some more about, because what is DSOC? What is this deep space optical communication, and why is it something that seem like it should already be out there in space? Here is Joel from the NASA Marshall Space Flight Center, and he's the mission manager for DSOC, so he's going to tell us what it is.
So Deep Space Optical Comm, we're effectively hitching a ride with Psyche out toward going past Mars and beyond. The key with DSOC is to demonstrate laser communications. Right now, we use radio comm and things of that nature, but if we can demonstrate laser comm, then we have the capability to have uplinks of 10 to 100 times greater than we have today. Not that we can get there any faster, but what we can do is we can have more bandwidth. We can send more information up at the same equivalent amount of time.
So laser communication, we know what this is. We use this all the time. Our houses are wired with it. It's laid across the ocean floor, so we communicate between continents. This is not something that is brand new. Now, yeah, Starlink wants to use internet in orbit, but for most of us, we're going to be using fiber optics for the foreseeable future. Why is NASA just getting around to this now? And also, it's not just the satellites that need to change, but our ground infrastructure here that need to change. So here's Joel with more stuff on DSOC.
So what we have is we have a laser transmitter that is based in the mountains in and around Pasadena, near San Bernardino, California, called Table Mountain. It's a property that has the capability to emit the laser beam up to the spacecraft as it's departing the Earth-Moon system and going out toward Mars and beyond. And then we have a receiver station that's at Palomar, which is down around San Diego. And so effectively what is embedded inside of the Psyche spacecraft is what we call a transreceiver, part transmitter, part receiver. And so it's like if you were a mile away from the target Psyche, you're pointing at a target that is about the shape of a dime. So it's very precise pointing requirements that we have to stick with, and that's what makes this technology so exciting, is the ability to use that laser and to aim it at the spacecraft as it's departing the Earth system and heading out, and then being able to transmit that information back to Palomar. I think anytime there's improvements in the technology and the capabilities we have, we're certainly trying to utilize those and make them operational for future use. The thing I would describe is about a decade ago, 2013, we flew a mission called LADEE to the moon. And that was where we first demonstrated laser comm. And so that's about 230,000 miles away. And then about a year later, we demonstrated that on the International Space Station, which is about 230 miles above the Earth. And then a couple of years ago, we flew laser comm relay demonstrator, also out of the TDM program office, and that was at geostationary orbit. And so what is unique about each of those is that those are things that are effectively orbiting the Earth system. What is unique about DSOC and what we're going to demonstrate with this mission with Psyche is the ability to hit a target that is constantly moving further and further away from the Earth. And so that is the challenging part, being able to, because it's line of sight, being able to target that spacecraft as it's going through its trajectory.
So DSOC is actually pretty important. Psyche is important too, but DSOC is this is an amazing technology that we might be able to increase how much science we're getting from space. So they're going to be testing it over the next couple months when this thing launches, and we're going to see exactly what we can do with it. And you know what that means? We might see better images, better live streams. Artemis 1 just launched, and we got phenomenal views from the moon. And we're going to be seeing that with humans on the moon in the near future, which is insane. But we're also, this technology might just make that better, because we've been using radar technology, which is what we used in the 60s to communicate with spacecraft. Yeah, there's been some changes and technology has improved, but now we're going to go almost to like the next generation of space communication with DSOC. And it's really, really exciting. We're going to learn so much more about our history of our solar system with Psyche. This mission is really, really amazing that we actually get to see it, and we get to see it on one of the, in my opinion, coolest rockets we've seen in a while launch. Hopefully it launches. We're watching some weather on Thursday. It looks like it's going to be pretty rainy, and so each day they're going to have a new launch attempt, and we'll hopefully be able to get to it over the weekend. Thank you so much for watching, and make sure you like and subscribe, and we're going to be bringing you some more video content out here on this channel, and make sure you head over to spaceexplorer.com to read up on all the latest news happening in the industry. Thanks for watching.